For the first time in human history, a spacecraft has dared to enter the atmosphere of the Sun. This historic achievement belongs to NASA's Parker Solar Probe, a mission so extreme that it challenges everything we know about heat, physics, and survival in space. The Sun is a raging inferno, a place where no metal should survive, and yet Parker's solar probe flies closer than ever before. So the question is simple: why doesn't it melt?
In the early 1900s, scientists studying sunlight made a shocking discovery. By analyzing the color and wavelength of light using spectrographs, they could estimate temperature. What they found created one of the biggest mysteries in astrophysics. The surface of the Sun burns at about 5,500 degrees Celsius, but its outer atmosphere, the corona, reaches temperatures of over 500,000 degrees Celsius. That's more than 100 times hotter than the surface itself. It's like feeling more heat as you move away from a fire, something that shouldn't happen. For over 100 years, scientists struggled to explain this mystery. The corona is usually hidden by the Sun's intense brightness and can only be seen during solar eclipses or with special instruments. To truly understand it, scientists needed to go there.
After NASA's formation in 1958, many space missions were launched. But studying the Sun's corona required something unprecedented, a spacecraft that could fly into it. The challenge was overwhelming. Iron melts at 1,500 degrees Celsius. Tungsten, the toughest known metal, melts at 3,422 degrees Celsius. The Sun's surface alone could destroy them instantly. So how could anything survive millions of degrees? But heat wasn't the only problem. Getting close to the Sun is incredibly difficult. To escape Earth, spacecraft speed up, but to fall toward the Sun, they must slow down dramatically. No rocket ever built could provide that much power, so NASA turned to gravity itself.
The solution was elegant and risky. NASA used Venus as a gravitational brake. By repeatedly flying past Venus, the Parker Solar Probe could gradually lose speed and spiral closer to the Sun. Not once, not twice, 24 times. On August 12, 2018, Parker Solar Probe launched on an 8-year mission. Each Venus flyby brought it closer. Each orbit allowed about 37 hours of direct solar research. Over the mission, nearly 900 hours of close-range solar science. Then came the historic moment. On April 28, 2021, NASA confirmed it. Parker Solar Probe had entered the Sun's corona. The mystery was real. The corona truly is far hotter than the Sun's surface. But the biggest question remained. No rocket ever built could provide that much power. So NASA turned to gravity itself. The secret lies in engineering brilliance. The side of Parker Solar Probe facing the Sun is protected by a revolutionary heat shield made of carbon foam. This foam is 97% empty space, making it incredibly light and resistant to heat. On top of it lies a carbon-carbon composite layer formed from graphite and resin, baked at extreme temperatures into nearly pure carbon. Finally, the sun-facing surface is coated with white ceramic paint, reflecting most sunlight before it can be absorbed. Everything behind the shield stays in its shadow. Even so, the probe can withstand only about 2,500 degrees Celsius. So how does it survive a corona that reaches 500,000 degrees Celsius?
The answer is surprisingly simple. Heat needs particles to travel. On Earth, air carries heat. That's why summer nights can still feel warm. In boiling water, heat transfers instantly because water molecules touch your skin. But space is different. The sun's corona is extremely hot, but also extremely thin. There are very few particles to transfer heat. That's why briefly placing your hand in a 300 degrees Celsius oven doesn't burn you instantly, while boiling water does. On Parker's solar probe, the heat shield reaches about 1200 degrees Celsius, but the back of the spacecraft, hidden in shadow, can drop to below freezing. No particles, no heat transfer.
And that is how humanity touched the sun. Not with brute force, but with physics, patience, and precision. The Parker Solar Probe is not just a spacecraft, it is a symbol of human curiosity and our refusal to accept the impossible.